When I run this script, all the actions are performed in sequence, one after the other. MaxScript also provides ways to control and alter the sequence of actions, and we'll look at a couple of them now. This is called the conditional, or if statement. This if statement chooses between one of two actions based on a test of some kind. In English, the example here says, if the currently selected object is further than 100 units from camera 1, set its segment count to 6. Otherwise, set it to 20. This is a very simple kind of distance-based level of detail adjustment. The words if, then, and else are reserved words and are always interpreted as defining an if statement. This is the test part of an if expression. It's comparing the result of a distance function to 100. The distance function is a built-in function that computes the distance between the pivots of two objects. The first argument to that, $, is a special name that denotes the current scene selection. The second argument, $camera1, is the camera for which we are establishing the level of detail calculations. So, this computes the distance between camera 1 and the currently selected scene object. This is the then branch of the if statement. It is executed if the test part is true. This is the else branch, and not surprisingly, it's executed if the test part is false. As I select and run it on objects at different distances, you see it affects the segment count depending on the distance, as expected. I want to digress for a moment and talk a bit about the layout of scripts on a page. I've written this example in 4 lines, but it could have been written on 2 or even 1, like this. Although MaxScript is flexible about this and lets you lay things out generally as you want, there are some rules about where you can break statements into multiple lines, such as before or after reserved words or after symbols and punctuations. These are described in the source code layout topic in the MaxScript help. The if statement can also be used as a kind of expression, yielding a value based on a test. If you look at the previous example, you can see that it is effectively choosing one of two segment count values based on a test. So I could have written it using an if expression form like this. This is a property assignment similar to those we've seen already. The destination is the segs property of the currently selected object, and the source this time is an if expression in which the then and else parts choose the value that will be assigned depending upon the result of the test. As it stands, this little level of detail script is barely useful. You have to keep selecting objects and running the scripts on each one. What we need is an easy way to run some script code on a collection of objects in one go. And the simplest way to do that is with the for loop, another sequence control construct. So here's the modified script. The for part causes the statement after the do to be repeated once for every geometry object in the scene. This part is called the source of the for loop. It specifies the collection of items we want to loop through. And geometry is a special built-in set that contains all the geometry objects currently in the scene. There are several other built-in sets like this, such as lights and cameras and so on, and you can specify other arbitrary collections in a number of ways. The word obj here is called the loop variable. It's like a variable in algebra and names a value that can change from time to time. In this case, MaxScript uses it to name each item in the source collection as we loop through them. Notice obj is used instead of $ in the original if statement. This causes the if statement to operate on the item named by the loop variable each time around the loop. In the scene here, we have 4 geometry objects, Sphere 01 through Sphere 04. So, when we run this script, the loop body will be executed 4 times, once for each sphere, and each time around the loop, the variable obj will take as its value successive objects, Sphere 01, then Sphere 02, and then Sphere 03, and so on. This same piece of code will work just as easily whether there are 10 or 10,000 objects in the scene, so you can start to see the power of scripting. Loops like this form a critical part of many scripts, and before leaving them just now, I'd like to show one other common kind of for loop. This is called the range for loop, and it iterates over a range of numbers instead of the items in a collection. Let's say I wanted to create 25 spheres in a line, increasing in diameter and just touching one another. This would be a bit of a pain to do by hand, the more so if I wanted 2500 rather than just 25. Here's the script to do it, and it'll do 25,000 if we want, just by changing the range number. In this variation, the source for the for loop is the range specification 1 to 25, and the loop variable is I. This says, loop over the body 25 times, each time making the loop variable have the value 1, then 2, then 3, and so on up to 25. The body being repeated is another example of the constructor we saw earlier. It creates a sphere in the scene with a radius and position based on the current value of the loop variable I. The first repetition of the body will make a sphere of radius 1, the next radius 2, then 3, and so on until we get 25 spheres with radii from 1 to 25. In order to make the spheres just touch, I need to space the centers out proportionally to the square of their radii, so I specify a position parameter on the constructor. This is given as an x, y, z vector. In this case, with the y and z coordinates held at 0, and the x-coordinate being the square of the loop variable I. The caret symbol here means raised to the power, so this is I raised to the power 2, or I squared. Notice I've used an algebraic expression here. In general, wherever you need to specify a value, it can be an arbitrary algebraic expression. Let's say I wanted to make the radius increase by 10 instead of 1. I'd simply factor in the radius delta like this. The asterisks here mean multiply, I times 10 and I squared times 10.